The fifth exercise becomes a little bit more complicated. So we are asked to write a RISC-V program multiplies all numbers in an array with a constant number without using the mul instruction. Now, might have been a good idea to split this exercise up into two parts, might do it for next year, where you write it first with a mul and then without a mul. This can help reducing the confusion. But let's look at the solution here. So, first of all, it's a little bit more overwhelming, this one. It can be a little bit more vague what happens. There's a lot more registers to keep track of here. It might be possible to do it with less registers, but these are the ones we have used, 6 different ones. So the data section is quite straightforward, but this is the first time we have defined an array. So this is how you can define an array in a data section. Now, one challenge here, and this is the same challenge as we faced in C, is the fact that you don't know where an array starts and ends. An array at a low-level concept is simply a collection of memory addresses, but you don't store the size of an array. You could create your own array data type, where you always store the size as a first element, so you could do 5 here, comma, and then the elements of your array would be possible, and then you've created your own convention, your own data type. What we do here instead is to save the size as a separate variable, which is almost the same thing. We also reserve a word in memory to store the size of the array. You can't do it without this. You can't make this dynamic without storing the size. So this is a problem you faced as well when you wrote a C function that wanted to print an array, a generic array. You have to pass the size to the C function because at a low level you cannot simply get this array. If you look at that in memory, this array 1, 2, 3, 4, 5, and then comes a 3 behind that in memory. So you can never know when iterating through this array in memory where this array ends. We know now it ends here, but we can only know that if we have the size of the array. Hard code this. All right. That's our data section. This is how we define an array. And then let's look at the implementation. So the goal is to multiply each of these elements, in this case by the constant 3, and then store that result back into that array. So when I execute this program, let's do that quickly. This is all going to be multiplied by 3 and the result stored in the same location. So as you can see now it's 3, 6, 9, 12, 15. Everything has multiplied by 3. And these values have not been because they're not part of the array. All right, great. So now let's see how that is done. First, I'm going to zoom in on the multiplication itself. Remember in last exercise, we have calculated a to the power of b. So a to the power of b, that's a times a times a, and we do that b times. Well, if you do a multiplication of a and b, that's a plus a b times. So multiplication and raising the power are almost the same thing. Remember that in last exercise we used a loop, and we simply initialized the loop counter to b. We decremented that by 1 each time, and then we each iteration we multiplied a with itself. Now we can do exactly the same, only now we start with the value 0, we add a to that, and we add a to that b times, if we're doing a times b. And that's how we're going to implement this. So T4 here will be our T4 will store our intermediate result of the multiplication, and T0 will be the loop counter in the multiply loop. So T4 and T0. So in T3 is going to be the current value. Let's say the value A. If we're going to do A times B, A is going to be in T3. T4 is going to store the intermediate result. It starts at the value 0. And T4 will eventually have the end result of A times B. So what's happening here in the multiply loop is we're adding T3 to T4. So if you do this once, you did A times 1. If you do this 2, you did A times 2. If you do this 3 times, you did A times 3, and so forth. Now, that's exactly what happens here. So we do this n times. And how many times is n? Well, that's the value of T0. So we do this b times. Basically, we're going to load the value of b in t0. We're going to load the value of a in t3. And so what's happening here is we're doing a plus a plus a plus a, and we're doing b times. And that's because b is loaded in t0, and we're doing a loop here. So we're decrementing this b value by 1 each time. And so this multiplication loop is exactly the same as the loop we had for the factorial last time. We start t0, we initialize that to the value b. We do that right here. That's the constant to which we're going to multiply. So we're going to do the array element times the constant, a times b. T0 will thus be initialized to the constant value. It will then be decremented by 1. And each time we decrement this by 1, we make sure to add to our intermediate result, add the value of a, which is the array value. So, to make this more concrete, I'm going to go and single step through this code. Let's go right up until the multiplication loop. So our label of mult loop starts at line 32 with the add t4, t4, t3 instruction. So let's look for that one. That's this one. A single step to there. Right here. Okay. So this is the first iteration. We now want to multiply in the first iteration 1 with 3. 1 is going to be the value that's being added each iteration. So the value stored in T3. And T4 will have our intermediate result. So as you can see, T3 is storing the value 1, which is in the next iteration, this will have the value 2, in the next iteration 3, and so forth. And then T4 will have the intermediate result. Currently, normally 0 indeed. And now const is our loop iterator, is the value 3. Const should be stored right now in T5, if I'm correct. Sorry, in T0. We're going to use T0 to do this. And T0 is right here, has 3. So this will be executed 3 times. T0 will go to 0. And this will add +1 each iteration. We can see that happen now. So first iteration, T0 has been decremented by 1. We've added 1 to our intermediate result. Second iteration, we're adding 1 again. T0 is now going to be decremented again. Last iteration, T4 is now 3 times 1, constant times 1. And this value in T4 now, that's the multiplication of the constant with our first array element. Our loop variable is now 0. That means our loop is done. And this branch greater than 0 will now fail. It will not execute, meaning the multiplication is done. This loop will execute as long as we're multiplying. And we store the result, which is 3 times the first element of the array. We store that back into the array. Now we only looked at the multiplication. Now let's look at the full program. It starts by preparing our registers simply. Making sure that T1 is a pointer into our array. And so we're going to use T1 as a pointer. And then it's going to point to the first element. We're going to multiply the first element. We're going to store the result here. That's what we just did while executing the code. And then we're going to advance the pointer to point to 2, the next element. And then we're going to do everything again. So that's what happens here. That's what the array loop is doing. The array loop multiplies an element of the array by the constant, and then it jumps to the next element in the array and it does the same thing again. So in the array loop, we're going to write a code that has to happen for each element. What is the code that has to happen for each element? Well, we're going to move the constant to T0. T5 contained the constant. We're going to move that into T0 because we need that for the multiplication. We're going to move 0 to T4 because we have to reset T4 each time. We don't want to keep the intermediate value here when we go to the next iteration. So each iteration of the array, whenever we're going to a new element, we clear our intermediate result in T4. And then in T3, which has the current value in the array, we simply dereference the pointer T1. So T1 is pointing to an element in the array. in T3, we need to actual value. We don't need an address in T3, we need to value. So we follow the pointer in T1 and get the value stored at that location, and we store that in T3. Then we can do our actual multiplication, as we just explained. Once the multiplication is done, we store at T1 the address of the current element. We store the result of the multiplication, so we overwrite the old value with 3 times or const times the old value. Done in this multiplication loop. After this store instruction, we now iterate through the array. So first time we execute this code, this will happen with T1 initialized to the array, but then we jump to array loop the second time, and the second time T1 will not be pointing to the first element of the array. No, we will increment T1 by 4, causing it to point to the second, and then the third, and the fourth, and the fifth element. And we stop by getting a loop counter going. So this is what we initialize array size to, right? We know we need to go 1, 2, 3, 4, 5. We need to advance our pointer 5 different times. That's stored in size. So right at the beginning, we have this T2 counter, and this is the counter for our array loop. It's initialized for the value 5. Each iteration we decrement it by 1, and we only stop multiplying elements of the array once T2 reaches 0. Once T2 reaches 0, this jump is not executed, so the end of the program is reached. But as long as T2 is positive, we still have an element of the array to go. This is already becoming more complicated. I hope this explanation was somewhat clear, but the clearest you're going to get it is by single-stepping through code like this and really trying to understand what's going on. Your implementation is going to probably look very different, might use different registers, might use less registers or more, but that's the general idea. A good way of building up this exercise would have been to first write this exercise with a mul instruction and then afterwards without, because this makes it just extra complicated.